In this video lecture, I am going to quickly explain to you what is a z-score. You must have come across this term z-score many times in statistics, but people are actually confused that what is this z-score. After viewing this lecture, you will be able to easily explain the meaning of z-score and its two major utilities, two major uses in statistics. One being assessment of outliers and the other being checking the significance of relationships or testing the hypothesis. Testing the hypothesis. So we basically use z-scores to check the outliers and test the laid down hypothesis. What do we mean by standardized score or z-score? Z-score is actually telling us how many standard deviations a specific data point on a data series sits away from the mean of that series. Say you are talking about height of adults. So you have taken in the height of 30 adults and you find a mean of that. And if you say how far is adult number 3, the height of adult number 3 from the mean value of the height, this is known as z-score and it is expressed in terms of standard deviations. Now to assess the outliers, we generally use a rule which says that z-score should be between minus 3.3 to plus 3.3. Now why this minus 3.3 to plus 3.3? Because if the z-score is beyond minus 3.3 or beyond plus 3.3, that means that data point is lying outside the normally distributed bell-shaped curve. This we can easily understand through the empirical rule of normal distribution, which I have explained in my previous videos also. So if this is a normally distributed bell-shaped curve, it has mean of 0 and standard deviation of 1, where mean is equal to median equal to mode. So in this case, the mean is 0 and standard deviation is 1. Now the empirical rule says that if I have a normally distributed population, in that case, let me plot it: minus 1 SD, minus 2 and minus 3 standard deviations. This is plus 1, plus 2 and plus 3 standard deviations. This is 0. So if we have a normally distributed curve, the empirical rule says that 99.73% of the data points lie within minus 3 to plus 3. How many? 99.73 percentage of all the data points will be lying within the range of minus 3 standard deviation to plus 3 standard deviation, right? And if I take minus 2 and plus 2, the empirical rule says that 95.45% of the data points would be lying within minus 2 to plus 2 standard deviations. And if I take minus 1 and plus 1 within this, the rule says 68.27 percentage of the data points will be lying within this range. So this standard deviation minus 3 to plus 3 is actually telling us how many standard deviations a specific data point sits away from this mean value, which is 0 in case of a normally distributed curve. So this is same as z-score. So if a certain data point is lying beyond this -3 or beyond this +3, then we say it is a outlier. It is a outlier. That's how you assess outliers, univariate outliers in SPSS. Now let us check how z-scores are used for testing the hypothesis. First of all, we check the z-score, which is obtained by dividing the unstandardized factor loading by the standard error. So once you divide it by standard error, you get the z-score. Now, the rule of hypothesis testing says if z-score is more than plus minus 1.96 in case of a two-tailed hypothesis testing, two-tailed test, then we are good to reject the null hypothesis. In case of a one-tailed, we check it at 1.645. So, in case it is a one-tailed test, we say that the z-score should be more than plus minus 1.645. That means either more than 1.645 or lesser than minus 1.645 on the scale. So why this 1.96 and 1.645 for rejection of the null hypothesis? Because we want to accept the alternate hypothesis. That's why we do hypothesis testing, right? So if this is 2, this is 1 and this is 3, so I would say that normally distributed curve lies between +3 to -3 standard deviations, right? This is -3, this is -2, -3 and -1. Suppose I am just drawing this to make you understand. So for a two-tailed test at 0.05 significance level, that is 5% significance level, 95% confidence interval, right? 95% confidence interval means that this region close to -2 to +2 standard deviations, as told to us by the empirical rule, has the concentration of 95%, exactly 95.45% of the data points, right? So when we are checking a two-tailed test, we have to leave 5% significance level, which is out of this 95%, right? So 2.5% over here and 2.5% on the left side, because in a two-tailed test we are not specifying the direction of the relationship. Direction of the relationship is specified in a one-tailed test. So in this case, this 2.5% and this 2.5% data points are lying outside the normally distributed range of 95%, and the z-score corresponding to this is -1.96 and this is +1.96. So that's why we say if the z-score is more than ±1.96, in that case we reject the null hypothesis, right? We reject the null hypothesis. So null hypothesis saying that there is no relationship between the variables, we reject it and we say there is a relationship between the variables. What happens in case of a one-tailed test is this rejection region. In case of a one-tailed test, we specify the direction. increase in coffee intake increases the blood pressure. Say this is our hypothesis, and the null hypothesis is increase in coffee intake does not increase the blood pressure. So, in order to reject this null hypothesis, we will have to prove that the p value is less than 0.05. That means it is insignificant. At 95% confidence interval we are doing the testing. So, in this case we are specifying that increase in coffee intake increases the blood pressure. So, in this case complete 5% will be covering over here. This is the 5% rejection region, and this is 1, 2, 1, and this is 1 and 2 and 3, right, as per empirical distribution 1, 2 and 3. So, in this case what you say is 1.645. So, beyond 1.645, which is the corresponding value in Z table at 95% confidence interval, for a one tail test you get a value of 1.645. So, in case the value is more than 1.645, that is Z is more than plus minus 1.645, for a one tail test we reject the null hypothesis and we conclude that there is a significant effect of coffee intake upon increase in blood pressure. So, there is a direct relationship between increase in coffee intake leads to increase in blood pressure. This is a directional hypothesis. So, I hope I have made it quite clear and you have now understood the two major uses of z-score. One is to assess the outliers and the other is for hypothesis testing, and now you are well able to use it for your study. I hope the session was quite interesting and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.